Okay, on to part 2 of the batch fitting. All of the initial guesses have been set for the 5 data files that we'd like to fit. So we can clean up the temporary graph. We don't need that anymore. And now we can click on Do the Fits. What this will do is it will sequentially fit these 5 files. It will fit them each 3 times to make sure that it's actually converged to a proper answer. And then the results will be saved both as a notebook and as a graphics file. Given that this is a rather simple model function and the data sets are well behaved, the fits go rather quickly, and in fact they're done. We can close these reports. That's simply the report from the last fit, and now we can find these on disk. So if we go to the Finder, we can see that there are now 5 Igor notebooks with the results, and then 5 graphics files as PNG files of the actual data fits. So if we select all of these results and open them, then we can see the results of the fits. These are a standard curve fitting report. You can see the fits are good. There's no errors from the fits. Everything here looks quite normal. But I'd rather have these in a more usable format. So what we can do is, under the macros menu and auto fit, we can compile the reports. And what it's going to ask to do is the actual number of parameters that it has to fit, and that is this number, which is 6, and then some sort of tag for it, just to know whether this is like version 1, or this is my favorite fit, or this is something that would identify this fit versus any other fits you might do. If you say continue, it'll go through all of the data sets, data set reports, and then present you with a compilation of the results in a text file, which you can then save, and also save you with a compilation in a table with the fitted file name, the chi-squared value, the parameter and error. Since the parameter errors were here were 0, it's clear those were fitted values that were held. Parameter 1, again, these are numbered in the same way that the parameters are numbered. You can rename these to better names if you like. The parameter 2, 3, 4, 5. And if you want to plot any of these, you can see what they look like. But you can see right away from the table that the parameter error, first thing that jumps out to me is the parameter error for parameter 1 here is actually much larger than the actual value. That merits a little bit of investigation. But to plot any of these, you can simply say new graph, and you can plot, say, what am I looking at here? Parameter 1. Parameter 1 versus calculated, which would plot it against a point number. And you can see that. And then to that, if we double click on it, we can add error bars, which would be plus or minus the parameter 1 errors. So you do it, and then we can see that for 4 of the 5 values, the fitted values and errors are quite reasonable, but there's a gigantic error bar on the point number 2, which is set number 3. And if we look a little bit closer at that, we can see this is actually very close to the contrast match point. The data there is very noisy with high error bars, so it's not surprising that the radius is rather ill-determined in this case. So in this way, you can plot out all the values that you've fitted for this entire series of data, and there's no limit on the number of data sets that you can actually fit with this. I've just chosen 5 here just to be reasonable. If you're tired of having all these notebooks around, you can either print them, and if you have a lot of them, this will take a lot of paper, or you can simply close them and get them out of your way. Another thing you can do is generate a list of the PNG files, and this will look on disk for them. And these, in fact, are the same 5 files that were saved for each of the data sets with a somewhat truncated data file name. And then, if this is the list I want, I can either edit this list and just delete a few of these that I don't want to see, but I want to see them all, and I can then lay them all out. You'll use this list, and I can see all of the graphs of all the fits all together. And if you blow this up a little bit, you can see that it's got the data, the fit, and the file name on here in a much more convenient format to print, and visually see if all of the data fits are good, and if one of them is not good, which one is not good, maybe, and then you can go back and work a little closer on a data set that may not be fitted well. So that's a brief description of how to do batch fitting. It's a very powerful tool. Again, it can be any number of data files. They'll all be fitted with the same model. I could have just as well fit all of these files with the smeared Gaussian sphere form factor. And in fact, since all of this is already set up, there's no harm in doing this. If I click Do the Fits, it'll go through and do all the fits with the smeared Gauss spheres. And since it fit well with the unsmeared model, it should fit just fine with the smeared version. And then if we look on disk, then we have 5 more. And instead of it being Gauss spheres, it's SM tag for smeared Gauss spheres. File names are truncated slightly because there's a file character limit in reading these files back into Igor, unfortunately. But there it is, batch fitting, and I hope it proves to be useful for you.